And I'm going to talk about momentum in 2 dimension. And in the paper you get 2 type of questions. The one is the 2 objects are collide with each other perpendicularly. The most important thing is the 2 objects are moved together. That is the first kind that you can have in the exam. And the second one is the 2 objects collide with each other, right, and they are moving after the collision. They are not fusing each other, they are moving separately. So that's the 2 examples that you can have. So let's see how we can answer this kind of questions in the exam. Okay, right, let me start with the there is an object, the mass m1, and which is moving with the v1 velocity, and it's collide with the m2 object with the going with the v2 velocity. Then after the collision, what happens? The both objects fuse together and they are moving with a v velocity, and they making theta angles to the horizontal line, right? So what we need to find is the velocity and angle they form, right? So to do that, what I am going to do, I am going to draw use vector method, right? So here I can represent this m1 v1, the horizontal momentum, and the m2 v2 vertical momentum. Then resultant momentum will be the hypotenuse of this triangle. So how do I find the hypotenuse? I add m1 v1 square, m2 v2 square, and square root of it. So then from that I will get the resultant momentum. So if I want to calculate the angle, this angle theta is tan, I can use tan theta. So tan theta equals m2 v2 over m1 v1. From that I can get the angle. Then let's see with the real numbers, right? So think I have a 2 kilogram object moving with 4 meters per second, and it collide with 3 kilogram object with moving with 3 meters per second. So then after that they fuse together and move with the v velocity. I want to find the v velocity and the theta angle. Right. For this so side I have 2 kilogram and 4 meters per second speed. So the momentum is 8 kilograms per kilogram meters per second. Upward direction, there is a 3 kilogram times 3 meters per second, right? I need to find this hypotenuse. Hypotenuse will be, this is 9 kilograms per meters per second. So how do I find the hypotenuse? That is 8 squared plus 9 squared and square root of it. So that will be the resultant momentum. So then if I want to find the angle, this theta, so how do I do it? Theta equals tan theta equals 9 over 8, simple, right? So you can find theta equals tan inverse 9 over 8. You can calculate this using your calculator, simple. Right, let's move into the second scenario, which is the 2 objects are not fused together after the collision. Let me see, let's take I will take this one, m1 v1 collide with a stationary object m2. After the collision, m1 moving with v1 velocity and m2 moving with v2 velocity, and making theta 1 angle to horizontal. This one is making theta 2 angles to the horizontal. and I will change this one to the v, that will be better, right? This is v, initial velocity is v, I am taking v, right? So then now I want to, first I need to divide this one into component. You know, v1 and m1 is the momentum. With the angle I write m1 v1 cos theta 1 to this side, and from this component m2 v2 cos theta 2. And if I consider about the vertical one, vertically the m1 v1 sin theta 1, and the other one, the vertical one downward direction, m2 v2 sin theta 2, right? So then now let's talk about the momentum before collision equals to momentum after the collision. Right? So then according to the law of conservation of momentum, I am applying only for now. First I am applying vertical momentum. What vertical component? Initially there is no velocity on the upward direction, so their momentum before the collision is 0. Then momentum after the collision is now upward direction m1 v1 sin theta 1, right? And I add the other one, but it is in opposite direction, so therefore I should put a minus sign, m2 v2 sin theta 2. From this I can obtain m1 v1 sin theta 1 equals to m2 v2 sin theta 2. This is my first equation. Let's consider about the horizontal momentum. Initially there was a momentum, right? Initially m1 v1 was there, right? So then initially m1 v were there, right? Then after that, after the collision we have two momentums. One is m1 v1 cos theta 1, the other one is m2 v2 cos theta 2. So I write here m1 v1 cos theta 1 plus m2 v2 cos theta 2. So both are like additions, reason is they are in the same direction, right? So this is my second equation. So in the exam they will provide you necessary information you to calculate. So the basic thing is you should be able to create these two equations. If you can do that, you can find answer for the any question given in the exam. So they will like this question contain, like they will ask about velocity, they will ask about momentum, they will ask about angle, and they may ask about is this collision is a elastic collision or not elastic collision. So how do you show that elastic collision? In elastic collision the kinetic energy will conserve. So you need to find the two velocities, then see whether find the kinetic energy before the collision, then find the kinetic energy after the collision. So then you can show that whether it is elastic or not. Let me see, try with an example. Okay, I am taking like 5 kilogram moving with 2 meters per second speed and collide with a 2 kilogram object, and then after the collision they move, okay, 5 kilogram object moving with a v1 velocity and the 2 kilogram object moving with v2 velocity, right? Then they will make, let's say they are making this one 30 degrees and this one is making 40 degrees angle, right? So then I need to calculate the v1 and v2, right? So how do I do it now? I will divide this one into component. The v1 5 into v1 cos 30, this one is 2 into v2 cos 40. Then if I consider about the vertical component of this momentum, 5 into v1, 5 v1 sine 30, the other one is 2 into v2 sine 40, right, with the angle cos. With the angle you write cos, and without the angle you write sine. That's the easy way to find the two components in a vector, right. So then I need to apply like in earlier, I need to apply the momentum vertically and horizontally, right, law of conservation of momentum vertically and horizontally. Like, okay, let me see, if I consider this side, right, okay, I'll take the vertical first. If I take the vertical momentum first, you can see initially there is no vertical momentum, but there is after that collision, right. So before the collision equals to the after collision, right. So before the momentum before the collision, right, momentum equals to after the collision, right. So initially 0, the upward direction we have 5 v1 sine 30, the other one in opposite direction, so minus sine 2 v2 sine 40. Okay, let me see, right, this is 5 v1 sine 30, 2 v2 sine 40, right. So then I get 5 v1 sine 30 equals 2 v2 sine 40, right. This is my first equation. Let's consider about the horizontal one. Initially there was 5 into 2, right, the momentum was 5 into 2, 5 kilogram into 2, and now finally we have 5 v1 cos 30 plus 2 v2 cos 40, right. So then I have 10 here, then 5 v1 cos 30 plus 2 v2 cos 40. So then I can obtain the ratio for the v1 and v2, right. Then subject any of v1 or v2 in this first equation, then substitute into the second equation, then you will find the answer, right. So if you can't figure this out, you can contact me. If you send a message, I will tell you how to do that. I think this is some maths. By after obtaining this equation, you should be able to simplify the question, right. I think yeah, thank you for watching. So I will add all the units in the future, right, when I start with the momentum, right. Thank you very much.